Okay. Oh gosh. I feel like this is getting to be old news, but yay, it's the fun stuff. Okay. So here we're going to look at the product rule. The product rule, which some people get super confused about the second piece that I'm going to go through here, states that the derivative of f of x times g of x is equivalent to, oh gosh, my pen isn't writing, f prime of x, g of x, plus g prime of x, f of x. And I'm going to write down the confusing bit in a second. And I'm not really sure why it's confusing, and you won't understand either when you see it in a second. So you could even write it so that the g of x and the f prime of x were flip-flopped, or the g prime of x and the f of x were flip-flopped, or, oh my goodness, see, it's really obvious right now. You could flip-flop these two. I mean, like the whole entire bits, not like this whole bit and this whole bit. And you could flip-flop this whole bit and this whole bit. It looks like I'm drawing slowly. The pen's having trouble keeping up with my movements. There we go. You could flip-flop them. Commutative and associative properties still hold. So that confuses some people some years, and it probably doesn't confuse you in this particular context. So when it comes up, hopefully you'll recognize it and you'll be like, oh, I remember Miss Marty talking about things and me being all duh and or I don't understand what the heck she's talking about. And you'll have some memory of this and you will know to come back to this in your notes. Doo-doo. Okay, now we're going to look at the derivative when y equals x cubed cosine x minus 2 sine x. So here, I took the derivative of the first part times the regular of the second part of this product right here and got this. Then I brought down the regular of the first part and the derivative of the second part. You do need to know the derivative of cosine by heart, and you do need to know the derivative of sine by heart. That will be on your drill, that will be added to your drill quizzes at the beginning of the second 6 weeks. It should be in there now, but I'm a little tardy this year, so that's okay. I'm sure you're not complaining. So we go ahead and simplify this, and we get a slightly prettier version of this, and then we're done. And once you have made that slightly prettier, we come down to the quotient rule. And the quotient rule has a song I made up associated with it, and the song is terrible. It really is. You're going to write down the low function times the derivative of the upper function minus the upper function times the derivative of the lower function, all over the lower function squared. Okay, now I'm going to sing. Brace yourselves, because this song will have you rocking in your seats. Ready? It's dumb, but it helps you remember. When you're doing this, the hard part is remembering which one of these two pieces comes first. So I made up the world's most idiotic melody, and P.S. there is a heavy metal song out there that I will post for you for your enjoyment. He does a much better job than I do. Here we go. Low, D high, minus high, D low. So I started on the low note, and that was the only way that I could ever remember to keep track of which one came first. So you always start with low, D high, minus high, D low. Yeah, I know the musical notes on the second one aren't in order, but the first one starts on the low note and goes to the high note. Low, D high. That's how you start. really hard to keep track of if you don't have any kind of mnemonic device, melody, even though it's idiotic or whatever, to help you with through it. But that's what's going on. Okay, so now we're going to look at an example of this, and we're going to look at sine x over x cubed. Now, if you are Cheater McCheater, which I was in high school, you would have used product rule. And I'm going to show you the product rule, and then I'm going to show you the quotient rule. And the issue with my method, which was always to change everything into a product, is that sometimes it gets really, really nasty. So you see, when you get this product, when you use this product rule, you get something that's relatively ugly. You would still need to, you wouldn't need to, but it might be easier to find a common denominator, so you've added in another step. However, if you find that derivative using the quotient rule, it's going to be a lot simpler. So we simply go I'm sorry, I go so slow when I'm writing and talking at the same time. Low d high minus high. Uh-oh. I'm losing the song, aren't I? Low d high minus high d low all over low squared. And oh my gosh, so much easier, right? Oh gosh, it won't write. There we go. Okay. Then we simplify that, and it turns out pretty. There you go. With a little simplification, I divided every term by x squared so that I could simplify it. Now moving right along to our next low d high minus high d low. Okay, we're going to talk about some tricky bits about the simplification here. We got, let me see, how do I want to talk about this? Okay, so 1/4, x to the 1/4 times x, we add the exponents, and 1/4 plus 1 will give us 5/4. Over here, we've got 2, or x squared times x to the negative 3/4, which would be 2 plus negative 3/4. And 2 plus negative 3/4 also gives us 5/4. Oops. Next up, that's just negative 3/4. 1/4 times 2 is 1/2. So the rest of it is pretty self-explanatory, but distributing those exponents, I realize, can be a challenge. Some of you are better with that sort of thing than others. We will be eventually doing a worksheet involving factoring with crazy exponents. Once you get to this point, honestly, most of the time, once you get to this point, you would stop. I wouldn't even go much further most of the time. But if you see an answer in your multiple choice answers that doesn't match what you have, you might have to mess around with it a bit. But stop as soon as you can. The faster you stop, the more likely you are not to make a mistake. I'm going to talk about what happens from here if you have to simplify. If you're feeling super ambitious and you don't have a multiple choice answer, you would go ahead and you would find your common denominator. You would first move this down to the bottom, which is where I got my 5/4. Then you would, 2 minus 1/4 would give you 7/4. So you subtract those like terms. Once you've done that, you see that you have a least common denominator here of 4. Flip that to the bottom. And 4 over 4 times 1 over 2 gives you 2. Hopefully you can figure that out. I really think most of you I'd say 99.9% of you should stop here. Then look at your ABCD answers and simplify as best you can. If you make mistakes, you might not be able to find your answer, but hopefully you will be able to. Did you see that remind text? Did you see the other remind text that came up? Okay. If you have a quotient in which the numerator is a constant, it's actually easier to write it as a function with a negative exponent and use the power rule. This was my trick when I was in high school. It wasn't a very good trick. Oh, I'm older than the hills though, and my teacher was a baseball coach, but he was definitely not Eberly. He was kind of he had the LAZY disease. Oops. I put that in the wrong place. He definitely had the LAZY disease, and he would just have us for the entire class period write the problems on the chalkboard, like, so-and-so, you take number 1, so-and-so, you go do number 2. And so 10 of us would be at the board at the same time writing out the problems, and that's how we would check our homework. Isn't that lame? To this day. Okay, here we go. I don't know when I got interrupted. So I put that in the wrong place. We get negative 18 fifths x to the negative 3. So yeah, my calc teacher was pretty lame, and he didn't finish everything we needed to know before the AP exam. So he's like, well, you can go ahead and take it, but you're going to fail it because we haven't even covered everything. Loser. So none of us took it because we were like, what's the point paying for something if we're going to fail it anyway? Isn't that lame? Loser. That's what he was. Ooh, you want to hear the rest of my stories about my high school teachers? Ooh, you're sitting on the edges of your seats. There is a reason I am a math teacher. I had a math teacher named Mr. Dickey. Oh my gosh, the name probably made you laugh, right? Or made your brain go places it probably shouldn't. And you're thinking, Miss Marty, no, she would never think like that. Yes, I do. Because the dude gave every single girl a C and every single boy an A. And the dude in front of me, he would copy off of me. And he'd get more wrong. And I would still get a C and he would still get an A. Anyway, Mr. Dickey was sued and fired. And it was kind of an exciting year. This was my freshman year. Oh gosh, I forgot the X. And I was like, I can do a better job than he can, so I'm going to teach math for a living. There's more to the story than that. Like where my name came from. When I was a little kid, my dad was convinced I was going to be a teacher. He's like, you should go by Miss Marty, not Miss Knot, because you're smarty, not a snot. Hey, guess what? It is Lola's turn for some tutoring, so I got to get off of this stinking thing while Dolly Parton sings in my ear, probably yours too. But I want to finish writing this one little bit, so I'm going to do that. So Mr. Dickey was kind of exciting. I'm trying to remember my calculus teacher's name. Like Branford Sanders. Anyway, I'll finish this problem as soon as I'm done with Lola. Take care. Bye. Okay, I don't remember where I stopped. So real quick, I'm going to go through this whole slide. So I apologize if I'm repeating myself. 9/5. 9 over 5x squared would be the same as 9/5 x to the negative 2. Subtract 2 from the power, bring the power down, and you get negative 18/5 x to the negative 3. Then we use the quotient rule for the derivative of the tangent. And we're going to get the derivative low, d high minus high, d low, all over low squared. Okay, don't forget to tell me if I don't put it up. I got to put up that really hilarious video. Okay, so here we go. We've got this beautiful thing where we have low, which is cosine. The derivative of sine is cosine, minus high, which is sine x, and the derivative of cosine is negative sine x, all over cosine squared. So here we can see that the derivative, oh, that's weird. The derivative the derivative of tangent x is just secant squared x, and you do need to memorize that. What is one of the tricky pieces in here? You need to remember that cosine squared x plus sine squared x is 1. That is a trigonometric Pythagorean theorem that you will be expected to memorize, not on this set of quizzes, but on the next set of quizzes. Eventually, I try to build so you don't have to memorize them all at once, but eventually you gotta know them cold. Okay. So we go through and we're going to find the derivative of secant x using the quotient rule. So we need to change it into a quotient. And we do low d high minus high d low all over low squared. So once we've done that low d high minus high d low, we end up with sine x over cosine squared x. And to simplify that, we rewrite the ratios in such a way that they simplify to tan x secant x. We can do that same thing with cotangent x and cosecant x. And if you would like to go through the process, you are more than welcome to. I usually find that the majority of my BC calculus class, most students in the class are future engineers, and their brains work differently than those of us that are mathematicians, in that engineers tend to want the formulas and just go with it, and mathematicians, we really like to explore the theory behind it. So if you are one of those math people, I trust that you can figure out how to use the quotient rule for both cotangent and cosecant. You can go through that process and prove it to yourself, is what I'm saying. Doo-doo! The derivative of cotangent is negative cosecant squared x, and the derivative of cosecant is negative cosecant x cotangent x. Now we're going to come down to our last problem, which is 3x squared tangent x, and we can use the product rule to figure that out. Now that we know what the derivative of tangent x is, we no longer need to use the quotient rule. So we are simply going to take the derivative of the first times the second plus the first times the derivative of the second. And there we go. The derivative of the first would be 6x. Bring down the second, which would be tangent x. Bring down the first, which would be 3x squared. Bring down the second. Take the derivative of the second, which would be secant squared x. And last bit. Some people used to be, in the past, my students were really tripped up by these questions. I must be doing a better job explaining how these work. So if you're looking for f prime of 2 here, you would first need to find f prime of x, which would be g prime of x, h of x, plus g of x, h prime of x. Once you've done that, and you kind of want to, most people need to do that first. Very rarely do I bump into somebody who does not need to do that first. Once you've done that, then you're just going to replace your x's with 2. And we find that g prime of 2 is negative 4. And h of 2, forgot my equal sign, h of 2 is negative 1, if your pen works. And g of 2 is 3. And h prime of 2 is 5. And there we find that f prime of 2 is quite simply 19. Doo-doo!